Put this black hole where the sun is, and the first thing that breaks is not a planet. It is the scale in your head. Mercury is gone from the picture almost immediately, and the old inner map of the solar system stops helping before the thought has even settled. You reach for a larger comparison, something safer, something with more room, and that fails too. What looked at first like an extreme object now begins to feel like a bad unit of measurement, as if the black hole is not merely larger than a solar system, but large enough to make solar systems sound provincial. So the problem is not how big this object is. The problem is that each way we try to measure it breaks, one after another, and we are left without a stable frame for what size even means here. We begin with a system that feels settled, almost instinctive. A star at the center, planets arranged outward, distances that can be imagined as empty space with occasional structure. Even without numbers, the layout holds together in the mind. Now place the black hole at that center and keep the same layout for a moment. At first, nothing seems to move. The outer planets are still where you expect them to be, circling at great distances, taking years to complete a path. But the center is no longer a point of light. It is a boundary, and that boundary is not small. The event horizon spreads outward, not as a dramatic sweep, but as a quiet replacement. The region where light cannot return occupies space that was previously just distance. What used to be empty between orbits is now claimed. Mercury disappears first, but not in a violent way. It simply no longer has a place in the system. Its orbit would fall entirely within the boundary, which means there is no orbit left to describe. That alone sounds extreme, but it still feels like an edge case, something happening very close to the center. So the mind shifts outward. Venus becomes the next reference, then Earth. These are distances people trust, not because they have measured them, but because they have seen them drawn, repeated, stabilized across years of explanation. The expectation is that these will survive as outer markers. They do not. The event horizon continues outward until the idea of inner and outer begins to lose its meaning. The structure of the solar system was built on spacing, on separation, on the idea that orbits exist as distinct lanes around a central mass. Here, the central mass is no longer a point organizing those lanes. It is occupying them. This is where the first frame fails. Not because the black hole is large in a general sense, but because the relationship between mass and space is no longer behaving like the simplified model people carry. A black hole of this scale does not just pull harder. It replaces regions that were once used to describe motion. The mind tries to correct for this by switching from size to mass. Perhaps this is only a matter of how much material is concentrated at the center, something that could still be understood through gravity alone. But mass does not explain the boundary. The event horizon is not a measure of how strongly something pulls at a distance. It is a measure of where escape stops being possible at all. That line, drawn not by material surface but by the behavior of light, is what expands. And as it expands, it changes what counts as space. The solar system comparison was supposed to give clarity. Instead, it has removed it. What began as a simple substitution, one object for another, now forces a deeper correction. This is not a larger version of the same system. It is a different kind of center, one that does not sit inside the structure we imagined, but overrides it. So the frame shifts again, away from planets, away from the familiar diagram of a solar system. That image was too small, not just in scale, but in structure. Now the comparison moves to stars. Around the black hole at the center of our own galaxy, entire stars trace long, stretched paths, pulled by gravity into tight arcs that take years to complete. Those orbits feel large enough to restore some confidence. They belong to a different category than planets, something less domestic, more appropriate for a black hole. For a moment, that frame holds. You can imagine a star moving through space, not circling a quiet sun, but a dense and unseen center. The distances are wider, the speeds are higher, and the system feels more durable under strain. Then, this black hole enters that picture. Not as a stronger version of the same center, but as something that begins to swallow the scale of those stellar paths themselves. The region where its gravity dominates stretches so far that stars are no longer just distant companions. They become part of a deeper structure, one that is no longer organized in neat orbital layers. The idea of a star maintaining a stable path starts to thin. Not because gravity stops working, but because the conditions for simple, repeated motion become harder to sustain. The deeper you move into this field, the more the geometry of those paths begins to stretch, tilt, and destabilize. So the mind adjusts again. If planets were too small and nearby stars are still too local, then perhaps the right comparison is not an orbit at all, but a region, a sphere of influence, a volume of space where the black hole is the dominant force shaping motion, heating matter, and redirecting trajectories. That sounds more stable. A region can grow without breaking its definition. A region can contain complexity without collapsing into contradiction. It feels like a safer unit. But even this begins to fail. Because the boundary of influence is not a clean edge. It does not sit like a shell around the black hole. It blends into the surrounding galaxy, where other masses begin to matter, where gravity becomes shared rather than owned. So the question becomes less clear. Where does this black hole stop being the center? And where does the rest of the galaxy begin? The comparison with stellar orbits was supposed to scale the problem up. Instead, it has dissolved the idea of a single, well-defined system. What looked like a larger version of a known structure is now behaving like a region that cannot be easily separated from its surroundings. And that means the second frame has failed as well. The comparison breaks in a different way once you stop asking how large this black hole is and begin asking where it belongs. Up to this point, the mind has been stretching familiar categories: planets, then stars, then regions of influence. Each step trying to preserve the idea that this object sits somewhere along a known ladder. Now that ladder comes into view. At the lowest end are stellar black holes, formed from collapsing stars, compact, intense, and local. They exist within systems, not above them. Their size, even when extreme, still allows the surrounding structure to remain recognizable. Above that, there are heavier candidates, objects that push beyond ordinary stellar collapse. These begin to blur categories, but they still behave as extensions of the same idea. More mass, more pull, but still confined to relatively small regions. Then come the supermassive black holes at the centers of galaxies. These feel like a natural top tier. They anchor entire galactic systems, shaping the motion of stars over enormous distances. For most purposes, this is where the hierarchy seems to settle. The scale is already difficult to grasp, and the role they play feels complete. But this black hole does not sit comfortably in that tier. It pushes beyond it. Not just in mass, but in the way its presence alters the surrounding structure. The usual picture of a galactic center assumes a black hole that governs motion while still remaining a distinct component within the galaxy. A powerful center, but still apart. Here, that balance shifts. The black hole begins to dominate the comparison itself. The surrounding galaxy no longer feels like the primary system with a central feature. It starts to feel like an environment organized around an extreme core that approaches system-level significance on its own. This is the turn. The earlier comparisons failed because they were too small, but now something else becomes clear. They were also pointing in the wrong direction. This is not a story about scaling up a familiar object. It is a story about crossing into a different rank. In this upper range, black holes are not simply larger anchors. They begin to alter how galaxies form, how matter is distributed, and how energy is released across vast distances. Their growth histories are tied to the earliest stages of cosmic structure, where conditions allowed them to accumulate mass at rates that strain standard explanations. So the hierarchy itself needs correction. Stellar black holes are not small versions of these giants, and these giants are not large versions of those. The categories separate, not smoothly, but sharply. What looked like a continuous ladder now shows a break. And once that break is seen, the earlier frames cannot be restored. Once the hierarchy breaks, the next instinct is to focus on the object itself, to bring attention back to the black hole as a single thing. That instinct does not hold for long. Because at this scale, the boundary of the black hole is no longer the main feature. The surrounding system begins to carry as much weight in the description as the object at its center. Matter does not fall straight in. It gathers first, drawn into a wide, flattened structure that orbits before it descends. This disk stretches outward across distances that begin to rival the inner architecture of entire planetary systems. Heat builds through motion. Friction between streams of gas raises temperatures until the disk shines with a brightness that can outshine the combined light of many stars. What was once imagined as darkness becomes a region of intense radiation, extending far beyond the edge of the event horizon itself. The scale shifts again. Now the black hole is not just a boundary, it is the center of an engine, one that processes matter over vast distances before that matter ever crosses the final line. The system has thickness, reach, and structure. Jets form along the poles, narrow streams of accelerated particles pushed outward at extreme speeds. These jets do not stop near the black hole. They extend across distances that can cut through large portions of a galaxy, shaping the distribution of gas far from the center. So the comparison expands outward once more. A solar system is no longer a useful unit. Even the region of stellar motion around a galactic center begins to feel limited. The black hole, together with its disk and jets, operates on a scale where the distinction between object and environment begins to blur. This is the deeper failure of the earlier frames. They treated the black hole as a contained thing, something that could be measured from edge to edge. But at this level, the influence is not confined to that boundary. It spreads through radiation, through motion, through the redistribution of matter across large regions. The galaxy itself becomes part of the measurement. Stars form differently under this influence. Gas clouds are heated, compressed, or driven away. Regions that might have collapsed into new stars are instead stabilized or disrupted by the energy released near the center. The black hole is no longer just sitting inside the galaxy. It is actively shaping the conditions that define the galaxy. And with that, the scale shifts one more time, away from size alone and into control. At this point, it becomes difficult to ask how large the black hole is without also asking how it became that way. Because reaching this scale is not a quiet process. In the early universe, matter was less settled, more evenly spread, and more willing to fall inward under gravity. Regions that would later become galaxies were still forming, pulling in gas from their surroundings. Within those regions, conditions allowed black holes to grow faster than they can today. That sounds like a simple advantage. It is not. Even under favorable conditions, growth at this level runs into limits. As matter falls inward, it heats up and begins to radiate energy outward. That radiation pushes back against incoming material, slowing the rate at which the black hole can continue to grow. So the system resists its own expansion. For a long time, this seemed like a natural ceiling, a point where accumulation would slow, stabilize, and settle into a more gradual increase. But the existence of these extreme black holes suggests that in some cases, that ceiling was bypassed. Either matter was delivered more efficiently than expected, or the early conditions allowed the usual limits to bend without fully breaking. Gas may have flowed inward along dense channels, or entire clusters of stars may have contributed to rapid mass buildup. The exact path is still under study, but the outcome is clear. Some black holes did not grow slowly. They grew aggressively, early, and to scales that now sit above the ordinary structure of galaxies. This forces another correction. The earlier comparisons treated the black hole as something that expanded within a stable environment. But here, the environment itself was unstable, feeding the black hole at a rate that changed both of them at once. Growth and structure were not separate processes. They were coupled. As the black hole increased in mass, its influence extended outward, shaping how gas moved, how stars formed, and how energy circulated through the system. That feedback loop allowed the central object to become not just large, but dominant. So the scale we see now is not only a measure of size. It is a record of conditions that no longer exist in the same way. When we compare this black hole to a solar system, or even to a typical galactic center, we are not just comparing dimensions, we are comparing outcomes from different eras of the universe, formed under different rules. And that comparison cannot stay stable. Because the more we understand how these giants formed, the less they resemble anything that fits comfortably within the earlier hierarchy. After all these shifts, the question returns in a quieter form. What does size still mean here? At the beginning, size felt like distance from a center, something that could be pictured as a boundary expanding outward. That idea worked briefly, then failed, then was replaced, then failed again. Now only certain measurements remain useful. The event horizon still matters, but not as a simple edge. It marks the point where escape becomes impossible, yet most of what defines the system happens far beyond it. The disk, the radiation, the extended influence, these occupy space that cannot be ignored. So the boundary is no longer the story. The region is. Even that word needs care. The influence of a black hole of this scale does not sit cleanly inside a fixed volume. It blends into the galaxy, then pushes outward through energy and motion, altering matter across distances that no longer feel local. The idea of a neat sphere of control fades into something more gradual. This is where units begin to lose precision. Comparing the black hole to a solar system now feels narrow. Comparing it to stellar orbits feels incomplete. Even comparing it to a galactic center carries an assumption that the object is just one part of a larger, balanced system. That assumption no longer holds. The black hole, together with its surrounding structure, becomes a dominant organizer. Not everywhere, not absolutely, but strongly enough that older comparisons start to sound like approximations rather than descriptions. So the mind settles on a different approach. Instead of asking how large the black hole is, it becomes more accurate to ask what scale it begins to influence meaningfully. Where does it stop being a local object and start behaving like a system-level feature? And the answer does not land on a single line. It stretches across inner regions where matter spirals inward and heats, across outer zones where motion is redirected, across portions of a galaxy where energy from the center alters what can form and what cannot. The black hole does not occupy all of that space in a simple physical sense, but it organizes it. That is the final correction before the ending. Size as a single dimension was never enough to hold this object in place. The phrase that opened this, larger than entire solar systems, now feels smaller than it first sounded. It was never wrong, but it was never the full measure. A solar system is a clean idea, a central body, a set of orbits, a structure that can be drawn and held in the mind. It gives a sense of order, of distance, of separation between things that move and the space between them. That frame lasted only a few steps. Then it broke, and each larger frame that replaced it broke in turn. Planets failed, then stars, then even the idea of a contained central object inside a larger system began to lose its stability. What remains is not a single number or a single comparison. What remains is position. These black holes sit at a level where they do not just exist within systems, they begin to organize them, to shape how matter moves, how energy spreads, and how structure holds together across large regions. That is the hierarchy that replaces the earlier one. At the lower levels, objects fit inside systems. At the upper levels, systems begin to form around the object. And once that distinction becomes clear, the original comparison no longer feels like a conclusion. It feels like the first discarded step in understanding where these giants actually belong.